23, the answer we need 3 comparisons, but several students give me 4 comparisons. So answer is 3 comparisons. Yeah. So 3, very easy. Yeah. Right. Oh, sort. Yeah. So here, sort. Yeah. All right. Yeah. Actually, there is one small difference. Yeah. So here, for a question like this, we like to use a diagram to help us visually see the picture. Yeah. Otherwise, we just write the formulas, it may take us a lot of time to comprehend our data. Yeah. So we need to get some impression of our data. Yeah. But that's not easy. Yeah. So here, if we just draw diagram, so x1 higher than x2, higher than x3, higher than x4. All right, yeah. Then x5 below x2, and x6 below x3. Now we want to sort this array, yeah, with minimum number of comparisons. Yeah. To do that, yeah, so we know first there is a partial array already in ordered, right? So this partial array ordered, and this ordered chain, its length 4 element long. The length of this ordered chain is 4. Okay, yeah, 4. So then only 2 elements are not in order. Okay, are not in order. We just put them in order, then we get sorted. But when we put them in order, which one we should do first? Yeah. Then you will get different answers. If you work on x6 first or x5 first, so one you get 3 comparisons, another one you will get 4 comparisons. Yeah. So that's the reason. Some students give me 3 comparison solution. Some students give me 4 comparison solution. All right. So if you work on x6, then you can do better. Yeah. So the first comparison, you compare x4 and x6. Because one comparison, you can put x6 in the ordered chain, right? Yeah. So you grow the ordered chain from 4 to 5 just by one comparison. Yeah, because no matter x6 greater than x4 or x6 less than x4, you get a longer ordered chain. Yeah. So there are 2 cases, but these 2 cases are essentially the same. So we only need to consider one of the 2 cases. Okay? Yeah. So after this one comparison, so we get a longer ordered chain, x1, x2, x3. Yeah, so let's make assumption x4 here and x6 here. Okay? Yeah. And x5 here. Then next, x5 we compare with x3, our second comparison, x5 and x4. Yeah. Yeah. Because we only need to consider the relationship of x5 and the bottom 3 elements. We do not need to consider top 2 elements. So you use the binary search way. You compare x5 with x4 as your second comparison. If x5 is greater than x4, you do one more comparison. If x5 less than x4, you do your third comparison between x5 and x6. So in this way, you need 3 comparisons. But if you work on x5 first, then you need 2 comparison on x5 and 2 comparison on x6. 2 plus 2, you get a 4, right? So if you work on x5 first, if work on x5 first, okay, 2 comparison to put x5 in the ordered chain, and 2 comparisons to put x6 in the ordered chain. So this, you get a 4 comparison solution. Right? Yeah. So here you can see we have a 3 comparison solution. Yeah. So sometimes the order is important. When you work on your data, usually you have different orders to work. Several orders, different orders. Yeah. So then you need to find the best one. Yeah. When you have several orders, so usually for different orders, your solution result could be different. Yeah. So you should be very careful choosing the best way to process your data. So here, process your data. The processing order is important. Okay? Yeah. So next example. All right. Next one. This last question. This next one, I'll give you in the hint. Yeah. Yeah, but I saw one student give me 12 comparisons. Yeah. So that's too many. Yeah, too many. Because based on my hint, if you give me 11 comparisons, you can only get 1 out of 4 points. Okay, 1 out of 4. If you give me 10 comparison solution, yeah, because this is the sorting way. You just sort these 6 elements. Yeah, so that you get 2 out of 4. All right. Then 9 comparison solution. Yeah. This is non-sorting way. Sorting will be the complete sorting, not partial sorting. Yeah. Yeah. 9 comparison, you can do partial sorting. Yeah. So 4 out of 4. Okay. Yeah. Then 8 comparison. The bonus one. Yeah. The bonus one, challenging bonus one. So you get 6 out of 4. Okay, 2 bonus points. Yeah. Yeah. This 9 comparison, actually pretty easy to get, this is full credit, right? Full credit. Yeah, because some student can get it easily. You sort x1, x2, x3, sort. So 3 comparisons. Then sort second subarray x4, 5, 3 comparisons. Then after that, apply the solution. Apply the solution of 3 more comparison for third largest. Total 9. Okay? Yeah. See? Yeah. Full credit. Yeah. Very simple. Yeah. So that's the 9 comparison solution. 8. Yeah. So that 8, then a little challenging, but I gave you an example related to this question. The example I gave you, find the median of 5-element array. Yeah. Yeah. But remember, in the hint, I point out one important fact. Yeah. But some students miss that. So the fact I pointed out in the hint video. Yeah. So when we find a median of 5. Median of 5 with 6 comparisons. But after we find the median, what do we get? What do we get after we find the median? So this question. Yeah. So I want to point important property out here. What do we get after we find the median? Okay. So what do I mean? Yeah. All right. For example, yeah. So here, median of 5. Let's assume we find median of the first 5 element. Find the median. Okay, first with 6 comparisons. Yeah. So let's say x3. Let's assume x3 is the median. Okay. Yeah. After we apply this median of 5 algorithm, then what do we get after that? Okay, what do we get? Okay, what do we get? 2 elements. We know. Yeah. So let me write a little more. We know what 2 elements are larger than the median and what 2 elements are smaller than the median. Smaller than the median. But we may not know which one is the largest, which one is the second largest. This is what I want to say. Okay, we know 2 elements are larger. For example, x1, x2 are larger than x3, but we do not know x1 is greater than x2 or x2 greater than x1. We don't know that. Okay? Yeah. So if you look at the video, how did I find the median of 5? You can see I didn't say which one is the largest, which one is the second largest. I found one element of that is in top 2 that I eliminated from consideration. After the elimination, we don't know if it is the largest or second largest. So that's unknown. Yeah. So if you want to know, really want to know which one larger, which, you need one more comparison. If you want, you need one more comparison to know which one is larger. For that reason, yeah, because one student used that median of 5 and gave me a comparison solution, but actually you missed this comparison. Yeah. That student told me, you know which one is the largest, which one is second largest. But after you apply one more comparison, you know it. Okay? If you're based on our original median of 5 solution, you do not know it. Yeah. So that's the one important point I want to point out. Yeah. Other than that, so you just look at my solution file. Yeah. Yeah. So even I will give you my solution, but your solution could be different from mine. Yeah. So when I grade your a comparison solution, so I need to check all the details. Yeah. I need to check your comparison one by one for all the cases. Yeah. So usually that part of grading, usually takes me a lot of time. Yeah. 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 For other questions, very easy for the grading, but this last question, when you work on a comparison solution, then I need to, follow all your logic and consider all the possible cases. All right, so that's the homework questions. Then I want to go to the heap examples, 4 heap examples. Yeah. 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 At least you have some examples you can study. Yeah. So because we want to cover this part in the final. Yeah. A few heap questions. Yeah. Oh, sorry. Yeah. The question not very hard. So if you understand the basic structure, so then not too hard. Yeah. So here, let me just show you these 4 examples. First one, given a max heap whose values correspond to the array indices from 1 through n, what is the smallest possible index for a node with height 2 in the heap? Yeah. Height 2. Yeah. So we need to be familiar with the nodes arrangement, distribution in the heap. Yeah. But we have the range formula. Remember, we spend a lot of time to develop the range formula for the nodes, heap nodes, max heap nodes with height h. Yeah. So we use that formula. Yeah. All right. To see that, yeah, let me draw this line segment representing the heap. Then the range for the heap nodes with different height number. Let's draw that, the range. Then you can answer this question easily. Okay, all right. First, let's consider the first height equals 0. Height equals 0. We know they are leaf nodes. All the leaf nodes with height 0. And what's the range for it? Remember, the range n over 2, floor function plus 1, right? So the lower bound, so here, this is lower bound is this number, upper bound is n. And all the nodes in this range, they are leaves. Okay. Yeah. So then, height 1. Okay. So the next height 1 range, upper bound and a lower bound. Okay. All right. So upper bound 1 fewer than the lower bound of the leaf range. So this lower bound, upper bound. Upper bound is n over 2 floor function. This number. Lower bound here. N over 4 plus 1. So this, all the nodes in this range, height 1 range. Then, next one, height 2. Upper bound n over 4. Lower bound n over 8 plus 1. So this is the range for the height 2 nodes. So with this understanding now, what is the smallest possible index height 2 nodes? So in this range, the smallest possible index is the lower bound, right? Yeah. So the answer is this lower bound number plus 1. Yeah. Okay? Yeah. If I ask you the smallest index for the leaf node here, smallest index for the leaf nodes, then you can write n over plus 1. Okay? Yeah. And sometimes I ask you smallest, right? Because when we have a max heap, we have to put the minimum in a leaf node. Right? Yeah. You cannot put the minimum in a height 1 node, right? Yeah. Because based on the, so here we assume all the distinct elements. Here we need to make assumption distinct. We consider distinct elements. Then the minimum has to be in a leaf node. The node containing the minimum cannot have any child, right? Yeah, because based on the max heap property, the value of a parent node must be greater or equal, but here we assume distinct elements, so there is no equal case. Yeah. So the value of a parent node must be greater than the value of any of its child node. So the minimum cannot be placed in a non-leaf node for a max heap. Yeah. Then, if I ask you, what is the smallest index for a minimum? What is the smallest index for a minimum? Then you should give me the smallest index for a leaf node. Smallest index for a leaf node. Okay? Yeah. Yeah. So that's this example. Next one, given a heap with n nodes, if we know that there are 40 leaves in this heap, what are the possible values you can take for n? Yeah. Yeah. So let's answer this simple question. Yeah. So this question is very simple, but here I give you the easy way to find it. For Rohan, for your question, why, so you said, why the height 2 at the right? So for your question, you need to look at the nodes. We developed the formula in the nodes, so you need to go back to look at the nodes, the formula part, the range. Find the range formula, range for height h nodes. Okay, so that range, the range is so remember we use I, right? Yeah. So n over 2 to the h plus 1 less than or equal to I 2 to the h. Okay, that's the range formula. Yeah, because your height h equals 2, so n over 2 plus 1, right? Yeah, so that's 2 plus 1, 2 squared. Yeah, that's the range formula. So based on our range formula, you get n over 8. Height number plus 1, 2 plus 1. Yeah, 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 yeah. Just find this formula. Yeah. In the notes. Okay. Yeah. All right. So now let's solve this simple question. Yeah, pretty simple. Yeah. Why? Because we know the number of leaves. So given n nodes in a heap. Okay, n nodes in a heap. We know the expression of the number of leaves, right? Yeah. So let's get the expression for the number of leaves. You can find it in the notes, right? So everything you can, all the formula we used here, you can find in the notes. Yeah. Number of leaves, seeding function n over 2. This is the expression for the number of leaves. And so we can set up equation 40. Then we need to find all the possible values for n. So we need to solve this simple equation. But this one has a seeding function. Yeah. All right? Yeah. So then, how to solve it? How to solve it? So for this seeding function, Yeah, so here I give a suggestion, a simple way to solve questions like that. We use the approximation way. We use the approximation method. So what's that? Right? Yeah. So we remove the ceiling function. Simple. Remove the ceiling function. If we remove it, we get a function slightly different from the original ceiling function, right? Yeah. Slightly different, but approximately equal. Yeah. Approximately equal, slightly different. So that's why I say we use the approximation method here. Yeah. So let's do the approximation like this. Just remove the ceiling. Let's solve this equation first. This equation very simple. N equals 80, right? Yeah. So you find the simple solution 80. Okay? Yeah. And you can easily verify this is a solution. So you have one solution. N equals 80. Yeah. But this question, you need to get all the possible values, right? Not just one, all the possible values. 80, yeah. Then you try to get all the possible, but when you get, so here you have a solution at 80, yeah. Then 81, 79. So you have two directions to go. Yeah. Starting from your current solution, you try to check two directions, left and the right, two directions, and see if you can get more solutions. Yeah. All right. So check. Check. If n equals 81 is a solution or not. Okay. Try this. 81 over 2. No. It's 41, right? Ceiling, because you round it up, so it's not a solution. Okay, yeah. So this 81 is not a solution. You stop. So moving up that direction, you cannot get any new solution. Yeah. So you should stop. Then you check 79. Okay, 79. 79. That's 40, right? Yeah. Round it up, 40. So this is a solution. So 79, you get a second solution. Okay? Yeah. But not done yet. Okay? Because 79 solution, how about 78? Is 78 a solution? So next you check. You check. N equals 78. $39, okay? Not 40. Not 40. So it's not a solution. Okay? It's not a solution. Then you should stop. After you hit a non-solution, you stop. Okay? Every time when you hit a non-solution, you in one direction, you stop. So finally you get two possible solutions, 79 and 80. So that's the way we can solve equations containing ceiling function or floor function. For floor function, we can also do it in this way. Okay, ceiling function or floor function. All right, so that's this example. Yeah. Try to understand this example. Okay, yeah, approximation method. Okay. Next one. Yeah, it's similar to the previous one, but this time we need to work on nodes with height 1 nodes. Okay, all right, yeah, height 1 nodes. To solve this problem, the range, right? Yeah. So let's start with the range formula. Range formula for height 1. Okay? Yeah. So the range formula, floor function n over 2 to the h plus 1 less than equal to I, less than equal to 2 to the h. This is the general formula. Yeah. But because our height is 1, so our general formula becomes n over 1 plus 1, 2. So 4. N over 4 plus 1 less than or equal to I less than or equal to n over 2. Yeah. This is the range formula. Okay? Our range formula. Yeah. So next question, set of equation. How many nodes in this range? We need to write that expression. Yeah. The expression for the number of nodes in the range. Okay? Remember, we use the upper bound number n over 2 floor function minus, not lower bound directly, the number that is right before the lower bound. Okay? So this is the number right before the lower bound. Okay? Yeah. So remove that plus 1. So the integer in front of, just right in front of that lower bound number, integer. Okay? So this is the expression. And we know this number equals 60. So we need to solve this equation. We need to find all the possible values for n, satisfying this equation. Yeah. How to do it, how to solve it? Yeah. Approximation way. Okay? Yeah. By approximation. Okay? Yeah. So we just remove the floor function. N over 2 minus n over 4 equals 60. That means n over 4 equals 60. So n equals 240. So we get one solution, right? So you can plug in, you check it. So it satisfies this equation. Yeah. All right, so that's the first solution. First solution. Okay? All right. Then let's use the, extension way. Okay? So we find one solution here at 240. Now we need to expand our solution by two directions. 241, 242 from the right direction, 239, 238 from the left direction, and so on. All right? Yeah. Yeah. All right. Yeah. So here, let's do 241 over 2 minus 241 over 4. Let's see what's this number. Okay? Yeah. So 120 minus 60 equals 60. Yeah. It is solution. Okay, yeah, so this one is good. 241. How about 242 minus 121 minus 60? Okay, yeah, so 61, not a solution, right? So you stop. Yeah, so right direction expansion, we should stop. Okay, yeah. So we hit a wall, right? So this cross sign tells you you hit a wall, so you have to stop. Then you do expansion to the left, yeah, left hand side extension. Yeah. So 39. Yeah. So then use space here. Yeah. 239 over 2 minus 239 over 4, yeah, equals, yeah, so rounded down 238, 119, right? 119, okay, minus, rounded it down, 5, then 30, 559, right? Also 60, okay? So 139 is good. Then let's check another one. 238 over 2 minus 238 over 4. 119 minus 59, also 60, also good. Okay, yeah. So here actually we have 4 solutions. Okay, we have 4 solutions, and you see the denominator 4. Actually, the number of solution equals this, you know, denominator. Yeah, this larger denominator. Okay. Not a smaller denominator, this larger denominator. Although you can test 237, yeah, but 237 you will not get 60, yeah, because 237 over 2 you get a 118, right? But 237 over 4 you still get 59. So the difference is 59, not 60. So if you test 200, you hit a wall. Okay, you hit the left wall. So both sides you hit the wall. In between you have 4 solutions. So your final solution 4. 238, 239, 240. 241. 4 solutions. Okay? Yeah. So that's the way you apply the approximation method. Where did n over 2 go? You're doing subtraction, right? N over 2 minus n over 4 equals n over 4, right? Yeah. 1/2 of n minus 1/4 of n, so you get a 1/4 of n. So n equals 240. Why we ignore? Yeah, because subtraction, you do subtraction. Yeah, can you see this equation? N over 2 minus n over 4 equals n over 4, right? 1/4. 1/2 minus 1/4 equals 1/2, right? By case 1 mean, yeah, of course, yeah, right? Yeah, yeah. So use 1/2 minus 1/4. So you have 1/4 left, right? Yeah, yeah, yeah. The flow function, why use flow function for this case? But sealing, yeah. The reason is, yeah, that's a good question. So if you ask me, yeah, I need a little more space. Yeah, let me look at. I have 5 minutes. I have 5 minutes. Yeah. Although I have another one, yeah, but let me explain your question. Yeah. So if I do not have enough time, yeah, let's just ignore it. Okay? All right. So here you ask me why that one we use floor, because that one n minus that one, we use this formula, equals, so we use the seeding function. Okay? For the leaf, we have this formula. Okay? All right. But for that height 2 nodes, height 2 nodes, we use, all right, so we use h, or 2 square minus 2 cube, and this one not equal to seeding function of n o cube. Okay? Yeah. Not equal. So this one we cannot use the seeding function. Not equal. So remember, less than or equal to, but may not be equal to that seeding function. Yeah. So we don't have the equal formula. Okay? The equal formula only true for this case. Only true for this one case. It's true. So we can use the seeding function. So for this case, we must use this formula. Okay? Yeah. When you work on the number of nodes, this is the exact formula. Okay? For the number of nodes, this is approximate formula, not exact. Okay? Approximate formula. Yeah. So you cannot use this. You cannot use this formula because not exact. Okay? You cannot use this formula. All right. So that's the difference. Yeah. All right. Here, although there is a last question, yeah, I think this is the last question. Yeah. 10 long. Yeah, but only one question left. Okay. So if we skip one question, it's not a big deal. Yeah. Yeah. So you can think about, actually this question is not hard. Yeah, not very hard. Yeah. So yeah, because we run out of time, so I do not want to complete this last question. Yeah. So we just stop right here. So here you can think about, if we do not have that accident, yeah, my PowerPoint frozen, if we do not have that, at least we lost the 5 minutes. If we didn't have that problem, then I can complete this last question. Yeah. All right, so that's all we have, and I will post the solution file soon, sometime tonight.
I had a quick question.
Yes.
So you said you were going to be making an announcement on like the final and what we're allowed to bring and everything. And
yeah, computer. Yeah. So I will. So you can bring the computer in a book if you reference books if you want to use. Yeah, but the most important thing, our class notes. The solution file. Yeah, because most questions very close to our homework 2 questions. Yeah. So you can use your laptop to access all of our course materials, but 2 things you cannot do. One is email. You cannot use your email, and another thing, you cannot use search engine. Okay? Yeah. So you cannot use your any communication software. So you cannot send out, check your message, send anything out, and you cannot use search engine. Okay? Yeah. But you can use calculators. Okay? You can even use online calculators. Online calculators you can use. Yeah. 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 I will put them in an announcement. Yes. thank you for reminding me. I forgot. Yeah, I forgot to post this announcement. Yeah. All right, will be the final be based on after midterm. Yeah. So not based on the midterm. So only homework number 2 and the heap examples. Yeah. So homework number 2 and the heap examples. Yeah. Yeah. So not a midterm. Okay. Yeah. So try to reduce the amount of work you need to prepare. Okay. Yeah. Just focus on new materials after the midterm. Yeah. Do you know if there are any questions that won't included in the, that is other than the heap? No. Yeah. I will not. So usually I won't give you completely new question types. Okay, old question types, but I just tweak a little bit. Okay, so the old question type, for example, finding third largest, second largest, median, sorting, that's we treat as old questions, right? Yeah. So no brand new questions. Okay, no brand new questions. Yeah. Don't worry. Yeah. So most yeah. So I derive from old questions. Okay, related questions. Yeah. Yeah. Any other questions? Yeah. If not, let's just stop right here. Yeah. Lee, can we, as soon as we finish? Yes. Yeah. You can leave as soon as you finish. Yeah. You can even leave. You can, yeah, as soon as you finish. Yeah. For example, you don't need a 2.5 hour. Yeah. If you just use 2 hours, yeah, you can leave. Yeah. So you can leave. Yeah. That's your time. Yeah. You have the freedom to determine how long you want to use that 2.5 hour. Okay. Yeah. So definitely, you can. Yeah. All right. So then we just meet Wednesday. Yeah. Hopefully the weather is good. Yeah. Hopefully the weather is good. Yeah. I haven't checked the weather. Yeah. Yeah. Otherwise, we need to do something different. Yeah. Let's hope the weather is good on Wednesday. Yeah. All right.